Hi guys, we're back. So this is part 2 of the compound angles lesson. This one's going to be a lot shorter than the first one. As you remember, I just was about to show that cos of A minus B is equal to the cos of A times cos of B plus the sine of A times the sine of B. I know it's riveting. You can't wait for the ending. Spoiler alert, it's a big twist. You're not going to expect it. And now, what was I doing? Right. Okay. So I'm going to do some common denominator stuff, right? So like I have to work this out, right? I can't use the compound angle formulas to show that the compound angle formulas are true. So I have to do something else. So I'm actually going to work out what pi over 3 minus pi over 6 is. And so pi over 3 is the same thing as 2 pi over 6. So I'm just going to scribble out what I wrote there. 2 pi over 6 minus pi over 6, which is the cos of just pi over 6. And that works out to, well, the cos of pi over 6 is root 3 over 2. Let's put a little stream there. And now we're going to look at the right side. And the cos of A, which is pi over 3, times the cos of B, which is pi over 6, plus the sine of pi over 3, times the sine of pi over 6. So I'm going to have to put all these guys together. Luckily, I know all these values. The cos of pi over 3 is just a half. The cos of pi over 6 is root 3 over 2. Plus the sine of pi over 3, which is root 3 over 2, times the sine of pi over 6, which is a half. And multiplying all these guys through, I end up with root 3 over 4 plus root 3 over 4, which is 2 root 3 over 4. And ready for the big reveal, we reduce the fraction to get root 3 over 2. Amazing! The crowd goes wild. And here's our most satisfying moment in mathematical proofing, where we say, therefore, the left side is equal to the right side. We have proved it. Draw a little box here. You can write it therefore the formula is valid. You can write QED, which is my favorite, which is Latin for quod erat demonstratum, which means which was to be demonstrated. It is essentially the mathematics version of a mic drop and stalking out the room. And you can insert extra expletives there if need be. Just don't do it in front of me. Okay, let's do it one more time for the sum of two angles inside a sine ratio, where A is going to be pi over 2 and B is going to be 3 pi over 4. So let's look at the left side. Is going to be the sine of pi over 2 plus 3 pi over 4. And we'll again use some common denominator stuff to say that the sine of, well, that's 2 pi over 4 plus 3 pi over 4 is now going to be the sine of 5 pi over 4, and we can use our unit circle or special triangles, realizing that this is pi plus pi over 4, so it's third quadrant, so it's going to have a negative sign, same answer as the quadrant 1 answer for pi over 4, but it's going to result in negative root 2 over 2. Looking at the right side, I would say that the sine of pi over 2 times the cos of 3 pi over 4 plus the cos of pi over 2 times the sine of 3 pi over 4. And I can work each of these out individually using my unit circle or my special triangles. And I get the sine of pi over 2 is going to be 1. Can't actually use special triangles for that one. We have to remember that's the 90 degree, right? So there's our circle. It's here on top. So sine is 1. And the cos of 3 pi over 4, well, that's second quadrant. Same as pi over 4 in the first quadrant, only second quadrant. And cos in the second quadrant we know is negative, so it's negative root 2 over 2, plus the cos of pi over 2, which is 0. And we can actually stop there because it doesn't matter what the sine of 3 pi over 4 is because it's already being multiplied by 0. So multiplied by something, but who cares what it is because it's gone. And this results in negative root 2 over 2. So the left side is equal to the right side. And That is, the formula is valid. Formula is valid. And I do believe that is the equivalent of like what the ancient Greeks used to use, like a face palm kind of thing, like in your face kind of. I won't ever say that again, I promise. Okay, so last problem is where we get an actual problem. So angle A is in the second quadrant, angle B is in the first quadrant, such that sine A is equal to this and cos B is equal to that. Determine their exact values. So let's take a quick peek here. So we have to find the exact values of cos A and sine B. So we have some ratios here. So angle A is in the first quadrant, so let's do that. We'll draw it out. So there's angle A, and the sine of A is 7 over 25. And as we know, sine, well, this is the angle, this is the opposite side, this is the hypotenuse. Oh, my bad. A is in the second quadrant. Sorry about that. So this is A here. And we're still the same though. Here's the triangle. And that is going to be 7 on the opposite side and the hypotenuse of 25. And then we have B. Excuse me, this is not A. This is A. And then we have another triangle here with B. And B is going to be, remember, cos of B is the adjacent side over its hypotenuse. So its hypotenuse is 13, and its adjacent side is 5. Now, if I want to find the cos of A, the cos of A is going to be its adjacent side over its hypotenuse. Okay, well, I can do that. I can use Pythagorean theorem in this triangle. So 25 squared minus 7 squared, all square rooted, gives me 24. Since it's in the second quadrant, though, it's going to be negative 24. So we can see it's going that way horizontally. And the sine of B, you can actually see the sine of B would be the opposite side over the hypotenuse. And so this opposite side, again, we can use Pythagorean theorem. So 13 squared minus 5 squared, all square rooted, results in a 12. So the length here is 12. So now that we have this information, the cos of A is going to be negative 24 over 25, because it's adjacent over hypotenuse. And the sine of B is going to be equal to the opposite side over the hypotenuse. So the opposite side is going to be 12 over the hypotenuse 13. So now if I want to find an exact value for cos of A plus B, I can just apply the compound angle formula. So this is several steps, kind of been guided through it, because if this didn't tell us we had to get it, we would have figured it out in the next step anyways, because we would have to find the cos of A times the cos of B, because it's a cos compound angle, so it's cos, cos, sine, sine with opposite symbol. And we get the sine of A times the sine of B. And so the cos of A is negative 24 over 25. The cos of B, which was given to us in the question, is 5 over 13. Subtract the sine of A, given to us in the question, is 7 over 25, times the sine of B, which we just derived, is 12 over 13. Now we just do top times top and bottom times bottom for each fraction and subtract them. So we get minus 120 over 325. Subtract 7 times 12 is 84 over 325 again. And negative 120 minus 84 is negative 204 over 325. There it is down here at the very, very bottom. And that is, in fact, our final answer. It is the ratio of